Great. So we have Ulf Wiger from the protocol team here today. Ulf, could you tell us a little bit about your background and how you came to join Eternity and work on the protocol team?
Okay, yeah. I have a fairly long background in the Erlang community. Back in the early 90s when I was working in Alaska, I came across Erlang. Actually going back home to Sweden, and I took a course at the university, computers in telecommunications. And Robert Wirding was there and gave a course in Erlang. So that's how I kind of discovered Erlang. It's a long time now. I worked then at Ericsson, Erlang Solutions, a couple of different places. But the last few years I've been a freelance consultant. And I was just coming out of a project in automotive, and I saw an ad that Eternity was looking for Erlang people. They did say you have to hit the ground running, so you need to really know blockchains. I didn't so much, but I did know the then CTO, Joel Raymond, since several years back. So I emailed him. By chance, we had actually just been in contact a week or so ago. It doesn't happen often, but it's like every other year or every 2-3 years, we exchange a few emails. So, well, I told him I was available, but I didn't know that much about blockchains, and but he pulled me in. So, and then I usually always try to get the Cubic team involved in projects because I like working with them, and it's not always possible. You know, sometimes you talk to customers and you try to explain to them the kind of testing and really advanced techniques they use, but it's a bit of a hard sell. I mean, it's amazing technology, but kind of hard to understand. But this time, you know, Eternity was all for it. So, you know, a lot of my friends sort of came in at the same time. So it's
the clan was down for the adventure this time.
Yeah, and it's pretty amazing. I mean, often when you're a freelance, you don't really get to choose your team. This time it almost feels, not that I'm trying to take credit for it, but it kind of feels like suddenly you got to work with all the people that you've known for years and think, wow, if we could just put a team like that together, the kind of things that we could accomplish. And now suddenly it kind of happened.
We can make a fine print, the Rockstar team put together by Ulf.
Yeah. No, it wasn't put together by me, but we happened to stumble in at the same time, and of course they did ask me also if I could recommend some other people.
I see.
I think Eric and Tobias were actually in negotiation. We came in at the same time, so.
I see. So how much of what your experience that you had with like Ericsson or like telecoms applies to blockchain? It's a kind of a new paradigm to have this mining thing that's validating. How much is applicable from your past experience?
Well, it's interesting. I would say it helps to have been involved in really serious industrial projects with complex functionality and very high demands on quality assurance. So that, and of course many of us have. So it's been fairly easy to bring that on board. But also, I could say that one of the interesting things is that I've worked with distributed systems and fault tolerance and safety for just about my entire career, like since the early 90s, and but they've always been based on trust in a sense.
Yes.
Like they're always closed systems where Well, you have perimeter protection. The way to protect against nasty code is that don't let it ever touch your system. So you trust all the components because you built them yourself, typically. And the algorithms for solving various problems, and especially solving scalability and fault tolerance, are all trustful. They all depend on trust. So in the blockchain world, you kind of have many of the same problems, but you can't reuse any of the existing solutions. And many times you feel like, well, yeah, here, this is a leader election problem. I've written several leader election implementations. Hans Svensson did his PhD on model checking leader election implementations. But those algorithms don't work.
I see.
Because you don't know if you can trust the other players, or the other nodes. So then everything is turned upside down, and you have to rethink everything. So it's not a complete loss, but it's also what makes it exciting. And in a sense, a thing that I think is often lost in when people talk about why blockchain technology is interesting. People usually focus on, crypto as a financial instrument. Is it a good investment, or is it a good database? Well, in many cases, no.
Is it real?
It's like the slowest database ever, almost. But from a technological point of view, it challenges many assumptions that were so hardwired that it really forces you to think along completely new paths.
I see.
And I think it's hard to foresee now what all the applications of that will be. But I think generally, to be able to develop exciting no-trust solutions in sort of a connected world that's probably going to leak out of the blockchain world and find implementations in a lot of different ways that we have a very hard time imagining now, because we're so used to thinking in a different way.
So speaking of applications, I saw you talk earlier about state channels, and I want to ask you to clarify a little bit. You mentioned, on-chain transactions, then opening a state channel, and then also opening a virtual state channel and closing it immediately. And there were each one got faster and faster in time. But what I didn't understand is in what situation. I mean, let me tell you what I understood. You can tell me if I'm on the right path or if it's completely off. So the way that I understood it, like doing a transaction in a virtual state channel is like, you may want to do this for some small amount. You're not going to send 1 million AE through that approach. Or in what context would you basically use a virtual state channel versus regular state channel versus no state channel, just like a smart contract on the blockchain?
So you could essentially the idea of virtual state channels is that you get away from the time it takes to confirm that the channel object has been created on chain. So, but at least with a solution we proposed, you have to then already have some kind of state channel with someone, say some reliable intermediary, or that you choose to, and then you can sort of deposit stuff that is your little state channel wallet, if you will.
I see.
Where you can pull funds and create small, short-lived state channels. The problem is that with very high value transfers in that case is that the intermediary will need to essentially match your deposit on both sides. So because the intermediary needs to sort of transfer tokens between the two state channels that are
Yes.
the respective parties' staging channels. So one could imagine that, say, if I wanted to field a service where people could create these state channels and I would stitch them together, I would probably put a limit on the total amount.
Okay.
Because I wouldn't want to have to
Yes.
post 1 million tokens into their state channels just to make sure that they could do transfer, or actually 2 million tokens then, so that
Yeah.
if one party wants to transfer 1 million tokens to the other, I actually have to move that amount from one channel to the other. And so the deposit that the intermediary has to put up, this is often the problem also with other types of distributed channel payments, where hash locks, for example, the relay has to lock the amount of funds that are being transferred so that it works out, and then you can recover it, but you're still locking funds. So that becomes.
What about complexity? So is there some situation where you wouldn't want to? I mean, I know that the state channel supports smart contracts in them, but is there some situation where I may not want to use a state channel because it can't support certain kind of complexity? I want to put it on the chain.
I think. Yeah, essentially when your stakes increase, you'll want to go to the chain.
Okay.
Because that's your safety, basically. So what we imagine, and what I was talking about was primarily, very fast, ad hoc financial transactions that are usually low value. And it's kind of trying to reach the nano payment space. You wouldn't buy a Ferrari that way, but buying coffee.
I see.
The sort of the just very easy flow of small amounts on the internet that could probably enable a whole lot of interesting social interaction.
It could open a new world of possibilities.
And also, if you optimize for the small amounts and make it so lightweight that you don't have to pay very high fees. I mean, the reason why, Visa is fast and all, the reason why they don't want to do this is that their fees are too high. There is no business case. Yeah. The way they are set up, this is uninteresting. It falls below their radar, essentially.
I see.
They are more into the higher value transactions. And so it's, you have to kind of pick the field you want to play on.
Okay.
And it's of course a challenge to figure out what would the interesting areas be where people could take an interest in blockchain or crypto and actually want to use it. And I think in many cases, the use cases where there are already perfectly satisfactory solutions are very hard to, you can do this basically the same way, but entirely differently, and possibly with some disadvantages that you're not used to. That's a very hard sell. So it's better to try to find something that the normal technologies cannot do.
I see. Okay. Well, thank you very much for coming to break it down for us and sharing your wealth of experience. We're excited to continue to have you on the team and continue to tackle these problems.
Thank you very much.